Hello, welcome to a video. I'm making a couple of these. If we need more, I can make more, but we're gonna go over this slide together. So about balancing. So let's see if this works. Oh, yay. Okay, great. So let's do the first one together. I always split it up at the arrow. So we have reactants versus products. We have nitrogen on this side, and we have two of them. And on this side, we have nitrogen, but we only have one, which shows us it's unbalanced. Hydrogen on this side, we have two. And hydrogen on this side, we have three. So it's very not balanced. So when we're balancing, I like to just pick one to go for to begin with. So start with nitrogen. If I have two here, I need two on this side. So I'm going to put a 2 in front. Remember, I cannot change any little numbers, only the numbers out in front. So this makes this one into a 2, and it makes this 3 into something else, because the 2 here and the 3 here are going to multiply. Now we have 6 hydrogen, because this effectively means we have 2 of this whole molecule, so we'll have 6 hydrogens total. So now our nitrogens are good, but we have to fix the hydrogens. So let's put a 3 out in front here, because that's going to multiply that 2 and give us a 6. So that is our balanced there. All right, let's do the next one. For this one, let's just do quick. K and K are balanced. Cl is balanced with Cl, but we have 3 O's and 2 O's. So I'm going to put 3 and 2. If they don't work out right, you can always do the least common multiple. So I'm going to put a 3 here to make 6 and a 2 here to make 6. So now my oxygens, I have 6 on this side and 6 on the other side. Now, this changed my potassium and my chlorine, though, because now I have 2 potassium and 2 chlorine. So I'm going to need to put a 2 here as well. So now if we double check, we have 2 potassium on this side, 2 potassium on the product side, 2 chlorines, and then 6 oxygens on each side. Cool. All right, for split elements, you need to make sure that you do that last. So if you'll notice here, when I'm talking about split elements, is that there's an O here and an O here in different molecules on the same side of the equation. So we're going to do the O's last. So on this side, we have 3 C's. We have 8 H's. Someday my iPad will work and I won't have to write with a trackpad. And I have 2 O's. We're going to do O's last. So let's start with C's and H's. On this side, I have 1 C and 2 H's. So let's do C's first. I'm going to put a 3 here because I have 3 C's on the other side. Okay, so now I have 3 C's. And now hydrogens, there are 8 and 2. So I'm going to put a 4 here, because 4 times 2 is going to make 8. So now our carbons and hydrogens are good. So now we think about oxygens. There's 2 oxygens right here. And on this side, it's a little tricky. We got to add up all the oxygens. So this molecule, 3 times 2, gives us 6. And this is just another 4. So we add up 6 and 4, we get a total of 10 oxygens on this side. Now, what we're going to do then is go back to this O and put a 5 here. We do the split element last just because it gets pretty complicated if we try to do it earlier. So I'm going to erase some of this stuff so that we have space to move on. Ooh, okay, polyatomic ions. Cool thing about polyatomic ions, if they stay the same in the reactants and products, and here we have SO4, SO4, they stay the same. You can treat that like one thing instead of an S and 4 O's. So over here, I'm going to write Al, let's do it this way, 1, Br, 3, K, I'll do the other ones on the bottom. K has 2, and I'm going to write a big S as our SO4. The whole thing has 1 SO4, so we have 1 total 1 on this whole side. All right, now let's go and do the product side. So on the products, we have 1 K, we have 1 Br, we have 2 Als. Also, it's never AI. There's no A element. It's always aluminum. And then we have 3 SO4. So I'm going to write it as a big S, remember, because I don't want to write SO4 out. So we have 3 of them over here, as we can see from this 3. All right, so where should we start? Let's start with potassium because it seems easy. 2 to 1. So let's put a 2 here. So now I have 2 potassiums and 2 bromines. Great. That might need to change later. It's okay. Now let's do aluminums. It's 2 to 1 also. So we'll put a 2 here. Great. So now we have 2 aluminums and 6 bromines. Interesting. Okay, we'll come back to the bromines later, I think. Next to our sulfurs, we're gonna need a 3 here because there's the 3 sulfates on this side and 1 on this side. So now we have 3 sulfates, but now my potassium is also at 6. So you'll notice, okay, so we'll have to go back and change that 2 we put here based on everything else. And that's totally fine to change what you're doing. So now because I have 6 and 6, I'm gonna have to put a 6 here. And let's double check our work. We've got 2 aluminum here. We've got 2 aluminum here. We've got 6 Brs and 6 Brs. We've got 6 potassiums and 6 potassiums. And we have 3 SO4s and 3 SO4s. Success. So sometimes like the ones you start with, you'll have to change later, but that's okay. Let's get rid of some else. Go away. Last one. This was a tricky one. I might have to do space below. Okay. All right. So let's write this one out. And I'm gonna, oh no, where did it go? I just lost my little tabs for drawing. Okay, well, let's do it anyway. Okay, so we have C, which is 8, and we have H, which is 18, and we have O, which is 2. And this is very similar to the number 3 we did. It's a split element also, so we're going to keep that in mind. So C, we have 1, H, we have 2, and O is split, and it's 3. So we're going to do the split one last. So let's start with, say, carbons. We've got 8 carbons and 1 carbon. I'm going to put an 8 here, because then I'll have 8 carbons. But it also means I'm going to have, what? This is 16. 8 times 2 is 16, plus 1. I'm going to have 17 O's. Okay. Now hydrogen, 18 to 2. 2 times 9 is 18. So this makes this 18. And now I gotta figure out our O's again. So we have 16 here, 16 O's. Sorry, 16 O's. And we have 9 O's. 16 plus 9 is 25 O's. All right, now this is the even odd problem because you'll notice everything's balanced except for oxygen, but I have 25 oxygens on the right and this left one can only be in multiples of 2. That's why it's called the even odd problem. There's no way to make this even number odd. So what we're gonna do is multiply everything we've done already by 2. So we're gonna have 2 here, skip the O's. This 8 turns into a 16, and this 9 turns into an 18. These are big numbers. That's fine. So now let's double check. So now I have not 8 but 16 C's here. And on this side I have not 8 but 16 C's. So the C's are still good. And I have not 18 but 36, I almost said that wrong, hydrogens on this side. And on this side, 2 times 18 also makes 36. So things that are already balanced will stay balanced when I do this. Well, that should be a 3. Okay. Now, last thing is to figure out those oxygens. So 16 times 2 for the CO2s is 32 O's from the CO2. And then 18 times 1 is another 18 O's from the H2O. And that gives us 50. You'll notice it's twice as what we said we needed before. And so actually what goes over here is that 25 that we already had found last time. And that will always work out that way. So that's how we do that even odd problem. And that's just some balancing help for you.